All right. Are we here? Sound test, sound test. Woohoo! Good morning. Woohoo! How's everyone doing? Oh, I think I'm on. It's the first time that I'm on time in a long time. All right. Good morning, good afternoon, good evening to everyone, wherever you're calling in from. I hope this live stream finds you well, whatever you're dialing it in. Happy Diwali for those of you calling in from India, or if you're like Indian culture, whatever you're living from. I believe this is the second day of Diwali. I have a lot of really good friends from India as well. We were going to draw one of those mandalas, but we never actually got around to doing it. Well, whatever. I'm not gonna get into that. Saeed, Monique, Chandra, good morning. How's everyone doing? Alrighty. What do I got going on here? My microphones are well, and I think everything else is working on my end. Yes. So let me find, while people are connecting, etc. Let me find a couple things that I need to figure out here. Why are we? Okay. All right. Okay. So how's everyone doing? All right. I am. What am I going to? What am I doing here? What audio? Audio? Where is audio? This thing is telling me that audio is not going through. Whatever. Monique, what are we doing here? Today we are finishing. We're wrapping up learning C#. All right. We remember how we. Yeah, I think it's working. I don't know what this thing is. Why is it not? We are finishing. We're finishing learning this. We're finishing the learning to C# playlist. Hopefully. So remember how we've been. Let me show my screen here. Where is the learning C#? So where is the learning C# playlist? Exactly here. We've done variables, flow control, arrays, lists. We've done everything except for object-oriented programming, which is probably like the most important part that we need to cover. So today we are going to spend both live streams together, and I'm going to be going over the concepts of classes, objects, how they work, how to use them, how to write them from scratch, and then, as an example, the last thing that I'm going to do is I'm going to write a full vector class. So we're going to write a class that represents vectors, and I'm going to use that to explain all the basic concepts that I will be explaining throughout the videos, and to explain a few more other perhaps advanced topics that I will not be covering explicitly, but that I will show through the example. All right. And with that, I think that's probably where I want to finish, like the introduction to computer programming playlist, because I think everything else that there is to learn, you can get away really, really far with all the concepts that are on this list, and everything else is basically more advanced topics that are not very common. They are common, but only if you're working at an advanced level, and you can get away very far without using those. I'm not going to be covering, for example, inheritance or polymorphism, because it's great, but I think you can get away without, at least at an introductory level. I want to remind those of you who might be new to the channel that we have a Discord where we have offline conversations throughout the week. I'm going to post the link here. This one is going to be permanent. I've been doing temporary links, so this is the first permanent one. This is going to work forever, this link. I also would like to encourage everyone who's watching right now to hit the subscribe button, notifications, everything, to be up to date to when we publish things. And I want to remind people as well that we have a Google Calendar where I post events of when we're doing live streaming. I typically do this over social media. We have an Instagram here, right there. If you follow that, you always get a story saying like, "Oh, we're going live next week, etc." Blah blah blah. But if you're more of a Google Calendar person, you can follow this link as well. And I don't want to forget about this. For my class, you know that I also teach an Introduction to Computational Design class here down the road at Harvard at the Graduate School of Design. And for my class, we're going to have a guest lecture this Tuesday by Maria Jablonina. Maria is an assistant professor at the John Daniels Faculty of Architecture in Toronto. She's also an extremely cool researcher and artist. She's done a lot of work in machines, swarms of robots, and using that medium as a creative design medium. So she's going to be talking a little bit about her work and what she's researching currently, and it's going to be super interesting. The lecture is going to happen within my class, so it's going to be in a private Zoom call that is only accessible to the class, but we're going to be live streaming the call in real time also to YouTube. So if you want to watch the lecture live, you can connect to this YouTube link here. Let me actually post a link here on the chat. You can connect to this call and you can be on the chat and I will be monitoring the chat. Oh, actually somebody already, yeah, Archie Coder. Oh yeah, I know him. He's actually Spanish. He's on the Discord channel. So if you connect to this call on YouTube and you post questions on the chat, I will be monitoring those and I will be able to relay them to Maria live. So it's going to be at 10 a.m. Boston time on Tuesday, next Tuesday. So if you're interested in her work, I really encourage you to check it out. It's really cool. She's she's very badass. All right. So with that, what are we? I guess we just have to get ready to start, right? So what are we doing today again? Classes. All right. So let me fire up some Visual Studio. Is this what I want to do at first? Wait. I don't have a project. Okay, so we're just going to do a simple console application. Where is it? Net framework, and this is going to be on my desktop. I don't even know what I'm going to call this. Wait. So let me see. What should be the number for this thing? We said 45, 50. So this should be 50 plus examples, something like that. All right. But before we do that, I'm actually going to open Firefox because I would like to talk about what classes and objects and all that stuff is. So yes, so C# classes, programming. Okay. Now, am I talking about structs anywhere? I have a cheat sheet that I wrote about what I want to be talking about. Maybe I want to. Excellent. All right. Alrighty. Yes. Okay, so let's start. Any questions before I start? Any comments? Remember that we're gonna have 2 live streams today, 2 hours in the morning, 2 hours in the afternoon. I will probably be recording videos most of the morning and the afternoon, but I will do a social and a Q&A right after each one of the 2-hour blocks. So we can have some more conversation in like a couple of hours when I wrap up this section, okay? All right, so what do I want to say here? This is going to be the first video in the section of object-oriented programming. And And I just want to make a quick introduction about the concept of classes and objects. I want to explain what we're going to be looking at during in this section, and I have here what is it that we're going to be talking, and what else do I want to do? I want to explain that we can think of this as a way of storing data, but we can also think of this as a way of creating like a high level abstraction of concept. Okay, all right, so let's do that. Okay. All right, are we ready for this? Woohoo! Am I very white? Wait, what is the lightning situation? Because I have two lights right now. Focus. Maybe it's too much. Am I very bright? What do you think? Am I very washed out, or so this is all lights? This is two lights, and this is one light. Does it make any difference? Hmm. Any strong opinions? This is one light. Okay. Two lights. Yeah, a bit means that it's too much, right? Okay, so let's do just one light. I think so too. Yeah, it's a little washed out. All right. So one light. Alrighty, let's do this. So yeah, let's stick to one light. Thank you. Mm-hmm. Hi. Okay, welcome to this new section in the Learning C# playlist. Nope, 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 nope. Going back. Again. Hi, and welcome to the new section on this playlist of how what starting over. Yeah. Hi, and welcome to this new section on the Learning C# for Designers series, where we're going to be covering the topics of objects and classes, which is the paradigm that is behind what's called object-oriented programming. The idea is that we have seen so far on this learning playlist, we have seen so far like a lot of the basic building blocks on how to create data and manipulate data. We've seen variables, we've seen lists, we've seen arrays, but it just so happens that in most modern programming languages, there is a higher level abstraction on how to represent data and how to manipulate it that is called object-oriented programming. And it's a common feature among most modern programming languages. So if you learn it here, you're going to be able to use it like in basically any other programming language that I can think of, except for C, which is a very low level one, for example. The idea is that just like we have seen, and I will explain that later, but just like we have seen how to store individual, blah, I don't know what I was going to, I don't know what I was going to say there. Let's start over again. Um, um, Hi, and welcome to this new section in the Learning C# series, where we're going to be discussing the topic of objects and classes, which is what's behind the more general paradigm of object-oriented programming. The idea behind object-oriented programming is that so far, learning how to code, we have seen simple ways of storing individual entry points of data. So for example, we've seen variables which represent unique values like numbers, booleans, etc. Or we have seen lists and arrays that represent collections of individual items of this same type. So collections of numbers, collections of booleans, etc. However, objects and classes are a super powerful way of storing more complex representations of data. So things that contain not a collection of data or not just single points, but multiple different types of data, representing very often a concept, an idea. And I will talk about what that means further down these videos. So one of the most interesting things is that object-oriented programming is one of the higher level and most common paradigms and patterns in any modern programming language that I can think of, except for example for C, which is fairly low level. So if you learn the basics of how to use and implement classes and objects in this list, you will be able to use that same idea in any other modern programming language. So what we're going to learn in this section is we're going to learn what objects and what classes is. I'm going to show a couple of examples. I'm going to discuss the higher level ideas or what it actually means in a more abstract conceptual way. And then I'm going to teach you how to implement your own classes with their methods, their fields, and all their properties, all from scratch. And then I will discuss a few more advanced topics, not very advanced. We're not going to get, for example, into polymorphism, inheritance, or all these like other structures. But we're going to teach you some more advanced topics, and I will do a full-blown example by the end of this section to teach you how to write a full-blown class with everything and like with everything. Why did I start it again? All right. I almost got it, so we're starting over again. Let's do it again. This is happening because I really want these videos to be good, so I'm sorry if I repeat these videos way too much. Okay, let's do it again. Hi, and welcome to the last section. No, I don't want to say it's the last in case I ever extend it. Going over again, starting over again. Hi, and welcome to this section in the Learning C# for Designers series, where we're going to be covering the topic of objects and classes, which is how we implement a more general idea that is called object-oriented programming. Object-oriented programming is one of the higher level and most common paradigms in all modern computer programming languages, except for example for C, which is a bit more low level. And the idea is that it's a super powerful structure because it's able to represent more complex entities, more complex data representations than anything that we have seen so far. If you think about it, we've seen variables, which are a way of storing one data point, a boolean, a number, an integer, a string, etc. Or we have seen also arrays and lists, which are ways of containing a collection of the same type objects. So for example, a collection of numbers, a collection of strings, etc. But with objects and with classes, what we will be able to achieve will be to represent more complex entities. So objects that contain different types of variables inside of them, different types of functionality, so different types of functions inside of them, therefore being containers that pack a lot of information of different types, but also in a more abstract way, being representations of higher level ideas with particular instantiations of values inside of them. I'll get to what that means very soon in these videos. So what I would like to do in this section is I'm going to show you first a couple examples of what objects and classes look like and what they mean. Then I'm going to cover from a more conceptual, theoretical, if you will, standpoint, what classes are and their relation to objects. And then I'm going to cover all the basics of how to implement your own classes and your own objects from complete scratch. I will go over all the basics and a few advanced topics. I'm not going to get very far. I'm not going to talk about inheritance, polymorphism, or things that are a bit more advanced, because I think you can get away very far without these topics at a beginner level. And then I'm going to wrap up the section with a full-blown example where I'm going to implement a large class all from scratch, and I'm going to use that to reinforce the topics that I will explain in the videos, but also perhaps tease you with a few more advanced topics that I may not cover explicitly in the videos. All right, so shall we get busy? Let's see. I'll see you in the next video. All righty, I think that was good. Okay, so the next video is going to be an example of what classes and objects look like. So I'm going to start with an example. And I'm going to, what am I going to do? I'm going to use the math class and the console class as ways of showcasing an object that contains functionality and contains properties. And then I'm going to show from scratch. Oh, battery. Okay, so I have low battery, so if I go silent, can you please blow up the chat, like you know? Okay, so please stay. If the audio drops, is my microphone, that is. All right, so I'm going to start by discussing the idea of encapsulating data. I'm going to write the console.writeLine, and then I'm going to say, like, hey, have you ever noticed how there's a lot of stuff here? And I'm going to use that to explain the concept of encapsulating functionality in an object. And then I'm going to show more of that with the math class that has a lot of functions but also has properties, because the console object doesn't have properties. Okay, so I think we're going to do that. I need to remember to speak slower, because I think when I speak fast, I accelerate myself and I can't keep up and I end up saying jibbly jabber stuff. So I need to remember to speak slower, because it makes me focus better. All right. All right, before we talk any high-level concepts, I actually want to cover a few examples of what classes and objects look like. And I have here a simple console application where I have written console read key, so that when I fire this, it just pops up somewhere, but it doesn't, blah, 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 blah. Why am I even explaining this? Okay, let me start over again. Start over again. I don't need to explain that. All right, before I start with any high-level concepts, I actually want to cover a few examples of what objects and classes look like. And the idea is that, for example, I have here a simple console application, and we are already very used to the concept of like writing console dot and then getting writeLine as a method that allows me to print things up to the screen, right? So for example, hello classes, and then I open and close, and then I can run this code, and this shows up here on the screen, right? However, let's take a closer look at what we have done here, because indeed, it turns out that we haven't really discussed what this console thing that I have here is, right? And if you look closely, when I type console and I type dot, what Visual Studio is giving me is this suggestion of a list of things that are inside of this console, whatever this is, right? And you can see that there are some different things. So for example, I have like the wrench icon here, and I have this kind of like purple cube kind of thing, all right? And I can choose between a lot of different stuff, right? This is a good example of what I mean by complex data structures that encapsulate inside of them a lot of properties and a lot of functionality. So the idea is that console is something that is given to us within the C# environment, is part of the system library that we have here. And we never question it, but somewhere in the code, someone has created something that is called console, and which inside of it has the possibility of writing a line, writing another line, reading a key, and it has like all this really cool functionality that allows me to interface with the console window. All right. We've given that for granted, but it turns out that this console thingy is actually an object. It's not really an object, it's actually a class, but I will get to that later. Let's think about this as an object right now, okay? And it is an object because it incorporates inside of it a bunch of functionality. So it has all these methods, for example, write line, write, simple write, it has read key, etc., which allow me to create or do something, right? Now, there I can choose console write line. I can choose, for example, what is this? Let me see. If I choose one of the wrenches, for example, this tells me what the background color is. And this is not a function. This is a property, right? So console background. So for example, sorry. Okay. I don't know what I was doing here. Okay. Okay, I lost track of what I was doing. What was I doing? Yeah, console background color. Console color. All right. Yes. So for example, I have the console background property, and because this is not a function, this is a property, I can actually read these from the console. So I can say, let me store this as a console color object, console color, and then store this here. And then let me actually print that console write line. Let's print the background color, and let's see how this works. All right. And you see that I get here the black output. All right. Similarly, you might be used to, for example, the math object. So you can see that the math object, if I click dot, I get access to a lot of functionality. So for example, calculating the square root of the value of, I don't know, 25, right? And I can print that to the console, right? Or something that I can also do, this is a function that is contained inside of math. Something that I can also do is I can print line the value of, for example, of pi. And you can see that in this case, pi is not a function, it's just a number, right? So I don't have to call it with the open and close parentheses. I just execute it. I just read it right away. All right. So what I want to say with this is that you can see how convenient it is in this case that the system is already giving us these two things, the console object and the math object. Again, they're not really objects, they're classes, but I will talk about that later. And how each one of these objects contains things that it can do. So the object can write things to the console, and then we can access that functionality. Or the object contains values. So the object contains the value of pi, the object contains the value of the background color of the console, etc. Right? And this is very convenient because if we were to, if the fact that this functionality or these properties are inside of this object is a very good way of keeping things tidy and making sure that we don't have like 17 million different variables in my scopes with the value of the background color, a function called WriteLine. Everything is contained inside of the object that actually uses this functionality for the same for math. So you can think of, for example, of the math object as a very complex structure that contains a lot of functionality, mathematical functionality, and some properties, the value of pi, the value of e, those kind of things. So it turns out that this is very convenient because it makes storing and keeping things very clean, very tidy, and it's much easier to understand and to read. If I only had a WriteLine function, then what the hell does that mean? But to me, as a human, it's a bit easier to understand that if I do console.WriteLine, it means that I'm writing a line to the console object. Or if I'm calculating the square root, it's a mathematical operation. So this hierarchy is actually not just easier to understand and to use, but it's also very convenient to keep programs clean, tidy, and things encapsulated wherever they should be belonging to. So this idea of creating structures that contain properties like the value of pi and functionality like being able to calculate a square root or being able to print to the console, this idea is core to what object-oriented programming means, and I'm going to show you in these videos how to actually create our own classes, our own objects, and be able to create functionality representing data structures representing this idea of encapsulation. All right. So let's take a look at what that means from a higher level perspective, from a more theoretical perspective, if you will. Alrighty. That was not entirely great, but write line inside the console class. Read the background color property of the console class. Use the functions and properties of the math class. All right, so I think that's good. How did that go? All right. So I'm going to now talk a little bit. I made a small PowerPoint. How do you feel about that, huh? That's a new thing. We don't really do that very often here, huh? Microphone still working well. All right, and okay. And my phone is telling me that Parametric Camp is live streaming. Okay, so let's talk about classes, and I want to say I have a few examples of what that means conceptually. All right, let's talk about what object-oriented programming means from a more conceptual standpoint. In my previous videos, I have explained how the idea behind objects is that we want to encapsulate data and we want to encapsulate functionality inside of a data structure. All right. So, for example, imagine that we were writing a program where we wanted to store or manipulate data that is associated to a person. All right. So for example, if we have a person called John Doe, we may want to store his name as a string, right? His age as an integer, his height as a double, right? And whether if this person is a student or not as a Boolean, right? If it's just this one person, we probably could be fine by using individual variables to store each one of the data points that make up this overall idea of a person, right? Now, but if we wanted to store like a second person, then we would have to go through a similar process where we now create more variables, but we may have to call them now name1 and name2, h1 or name h2, height1 or height2 for Jane, which is also going to have like her age, her height, and whether if she's a student or not, right? So, okay, maybe if we're only storing two people, maybe this could be okay, but it's already, for me, that I have like a small degree of OCD, for me it's already a painful thing to have to like have this variable name1, h1, name2, h2. It's confusing. It's a little, my program would not be clean. And also, if I had more than two people, you can see how easily this gets out of control, right? So perhaps the idea behind objects is that it feels convenient to be able to say, well, let me create something that is going to be called John, and is going to be representing all the properties that John has: name, age, height, and student, right? So if I were able to say, let me create something called John, and then John is going to contain a variable inside of him, which is going to be the name, and which is probably going to be a string, another variable called age, which is going to be an integer, the height, and the student as variables that belong to this more complex thing that we're calling here John. All right. This is what would be an object containing different properties, different variables for each one of these. And for Jane, we could do a very similar thing where now we're going to create a Jane object, right? Which is going to contain similar, identical properties, name, age, height, blah, 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 but with different values because it's a different person, right? What's very interesting about object-oriented programming is that objects are this higher level structure. So John and Jane would be an object, right? Each one of them containing properties, name, age, height, and whether if they're a student or not. And then it becomes very easy to store those variables inside of those objects. But what's also more interesting is that very often when we are, and you can see how these objects, John and Jane, are kind of representing a higher level idea, which is a person, because most people that I can think of, they probably all share these common properties: having a name, having an age, having a height, and whether if they're students or not, right? You can calculate that for any person in the world, probably. So it turns out that this idea, but each one of these particular objects, John and Jane, would have different values for each one of these properties. So this idea, the idea that we can create objects with different values for different properties, but all the objects kind of have the same pattern. They follow the same template. They all have the same overall properties, but with different values for each one of the different instantiations. This is the core idea behind object-oriented programming. The idea is that if I know that I'm going to be writing a program where I'm going to be storing, representing, and managing a lot of different people, right? Maybe I should be able to create some kind of structure that represents people in general. So I can call that a person class. And then I can design what are going to be the properties or the functionality that these objects, these people, are going to have. So for example, we can define that any person that I represent with code will have a name, an age, a height, a weight, and whether if they're a student or not. And I will also be able to give those objects functionality. So whether if they can talk, they can walk, if they can run, or they can die, you know? So the general idea, the concept, the template, the design of what kind of properties and what kind of functionality objects may have, this is what's referred to as classes, Classes is the general idea, the template, the pattern that all objects will follow. And then particular objects, so John, Jane, myself, Jose Luis, whoever is watching this stream right now, particular objects may have different values for each one of the properties, which will be the same. So all people will have names, but each person will have a different value for those names, right? They will have John, Jane, etc., right? And arguably, the way these objects will behave, the way they will talk, the way they will walk, the way they will run, many of those functionalities may actually be affected by the values of these objects. So if we had a property called where the person was born, then the way they would talk would probably be different. I have a Spanish accent because I was born in Spain, right? Probably the way they run might be affected by their weight, right? If they're a little thinner, maybe they run faster. Maybe their age is also affected. The running is also affected by their age. Younger people may run faster than older people. But that functionality may also be not affected by their properties. So arguably, everyone is going to die at some point, you know? So, so maybe that is not a factor. We'll see examples of how this is. So this idea that we can have a general class as the template that defines what properties and methods any person will have. And then we have particular instantiations of that class called objects containing different values for those common properties. This is the core of object-oriented programming and the relation between objects and classes. Now, object-oriented programming was, I believe, the first instantiation of objects was in this old programming language called Simula, which was derived from Algol. I'm talking about the 60s and the 70s. But the main programming language that actually popularized object-oriented programming was Smalltalk. Was an Apple-based programming language that was created by Alan Kay, who's a very famous computer scientist, very much in the realm of like cognition and how humans relate to computers. It was so popular, it became so popular and so novel that it actually was picked up by most of the modern programming languages that are out there these days. And I want to make two analogies of what the relation between classes and the relation between objects is, because this leads to a little bit of confusion sometimes. The idea is that, as I have explained before, when we have a class, the class is the general idea, the general concept, right? So, and then objects are different instantiations of that general idea. So if we think, for example, of a car factory, we know that a car factory will be producing cars. So a class that we call a car, that will be the factory, will be able to churn out many different types of cars, but they will all share some properties. They will all share number of wheels, they will all share the color, they will all share like how many cylinders each car has. However, each particular car that comes out of this factory may have a different color. So some cars will be red, some cars will be black, some cars will be blue, I don't know. Most of the cars will probably have 4 wheels, but some of them may actually have 6 wheels if the factory produces trucks, for example, right? The number of cylinders may vary, okay? And then as a consequence, how fast these cars can go may actually be in relation to how many cylinders the engine has, but will probably not be affected by the color, arguably, right? So in this metaphor, the factory that produces the cars would be the class, because it is what defines all the properties that all cars have. And then each one of the individual cars with their particular values for their properties, color, cylinders, number of wheels, etc. Each one of those will be the objects. So classes are the template and objects are the individual instantiations with actual data inside of them. All right. Objects here. A bit more, perhaps like a bit more high level example. I don't know if you're familiar with philosophy, with Plato's philosophy, and Plato's allegory of the cave. But if you are, basically in his philosophy, he used to argue that us mortals in the real plain world, we kind of don't. The way it works, knowledge for us in the plain mortal world is defined by this allegory of the cave, which is basically the fact that we all know what a horse is, all right? So if we see a horse, we all know that horses have like four legs, they have a neck, they have like tail, blah, blah, blah. So as humans, all of us can identify horses if we go out in the street, if there were horses in the street, whatever, all right? And even though if anybody asks like, hey, what are the properties of a horse? We would all answer that they have to have four legs. If we actually happen to see a poor horse that only has three of them, we would still identify this horse as a horse because there's something that makes us know what that horse is. But he would argue that as mortals, that this idea of horseness is actually something that belongs to the divine world. It's something that the idea of what an ideal horse is, an ideal person is, an ideal cat, an ideal tree, all of those ideal ideas live in some kind of divine plane that us mortals don't have access to, but we inherited that knowledge somehow, and that's why we are all able to know what a tree is, what a person is, even though they may have different properties, but we don't have access to the ideal tree or the ideal horse. In this allegory, it's also a little bit of how classes and objects work. Classes would be these ideal templates that live in the divine world, right? That they're not horses or they're not people themselves, but they are the ideal of what a horse of what a person is. And then in the actual plain world, we are around people, we're around horses, and we can see them, and each one of them is a bit taller, a bit faster, they have different colors, etc. But we can all still recognize them as being part of the more general category of horses. All right. So this is a little bit of the conceptual difference, all right, if you will. I don't know which example you relate better with, but those are my offerings here. If you want to learn a bit more about object-oriented, I have a full lecture in my Introduction to Computational Design lectures here at the GSD, so you're welcome to check this out. All right. So enough with theory. How about we actually start talking and start writing our own classes and creating objects from those classes. All right. So let's move on to the next video and let's start from scratch. How does this work and how do we implement this code-wise? All right, let's do it. Woohoo! How was that? Was that very conceptual, very high level, or was it doable? Which example do you relate better to? The car factory or the allegory of the cave? What do you think? I keep having to teach this a lot, and I never know what people relate to better. So I just use both examples and with the hope to catch everyone. I'm going to change. I'm going to go mute for a second. I'm going to change my batteries. Hold on. Back. Yes. All right. So cars. People relate to cars, right? Yeah. Perhaps the Plato, the philosophy example is a little too high level. Anyway. All right. So where are we? We're going to create a new project. Yes, so let's start a new project here. It's going to be Net Framework. It's going to be 51. And what are we going to do? Simple class. Let's do a person class. Let's stick to the example. Yes. Yeah, save that. All right. And I like that you're saying will we divine writing. I know, right? We're going to be like gods. We're going to be creating, designing our new things and creating, instantiating them, right? The gods of code. I like your name though, Spunky Dead Cat. I'm not sure if I've seen you around, but welcome to the channel. All right, console read key. All right, we're going to start with that, and we are going to start by creating a class. We're going to start simple. All right, and I have a typo here, person calls. All right, let's start by creating a class. And you can, all right. All right, let's start by the beginning, and let's start by creating our first simple class. We're going to be working on an example where we're going to be creating classes that represent people. All right, and remember, keep this in mind. Whenever we define classes, what we are defining is the general template or the general pattern that all person objects are going to be following. So whether if they all have age, name, blah, 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 and what kind of functionality they do have. All right. This is what we do when we define classes. So the way to define a class in a console application, for example, is that we need to go all the way outside to the most parent scope. That is at the same level where we have this other thing called a program class. Oh, this is suspicious. Wait, console applications are actually program classes. What does that mean? I'll get to that farther down in the videos, okay? But we need to go back to this same level. And the idea is that we create classes by using this structure called classes, all right? So the way that works is that I'm going to write the word class here, and I'm going to write the name of that I want to give to this class. I'm going to call it person, all right? And then I'm going to open and close curly brackets, and then I'm going to leave it like that. Now, that's it. That's the only thing, that's the baseline that I need to create classes that represent people. Obviously, this is going to be empty right now, so people are going to have no properties whatsoever, but I will get to how that works and how we add more properties in the next video, all right? What I want to show you is that this is the actual class. So this is representing the idea, the template. I'm going to write here template for person objects, all right? But now, anytime that I want to create a person object, so one copy with particular data of this overall idea of a person, what I need to create is an object. And the way to do that is by saying, I'm going to define something that is going to be called Jose Luis, all right? It's going to be a variable. And this variable is going to store a new object of the type person. The way that works is that we have to use this other keyword that we haven't seen yet, which is called the new keyword. I write here the name of the class that I'm going to be using. I'm going to open and close parentheses, and I'm going to put a semicolon here. What I'm doing with this is that I'm saying, hey, person class, can you give me a new object of yourself? So imagine the car factory example that I just explained. Imagine that this is kind of like calling the factory and saying like, hey, can you give me a car? And then they send your way a car with a particular shape, particular colors, whatever. All right. So the new keyword is what we use to ask for new instantiations of this class, aka to ask for objects. All right. So Jose Luis is going to be an object of the type person. But I get an error here, and the error is that the name Jose Luis doesn't exist, blah, blah, blah. It's basically telling me that if this is a variable, I need to give it a type, all right? Because this variable doesn't have a type right now. But what is the type of this variable? Is it going to be a Boolean, a string? What is this going to be for a type, right? We don't know what that type is. What actually happens when we work with object programming, object-oriented programming, is that classes, the classes that we define, become new types that we can use for our variables. So Jose Luis is not going to be a string, it's not going to be a Boolean, it's not going to be an integer. It's actually going to be a person. So this variable is not going to be of the type string, it's going to be of the type person, actually. All right? So people are, if I create new objects from the person class, they're actually of the type person. And this is very interesting because creating classes not only means data, complex data structure, etc., but it also means creating new data types that our programs can understand, that they can manipulate, and that they can use to talk to each other. All right? So by creating classes, we also implicitly are creating new types for variables, which is super, super neat. All right? All right. So, but now, what is going on with Jose Luis? Well, if I actually print Jose Luis to the console and I run this program, you're going to see that it just gives me nothing. Basically, what it gives me is that I have something of the type person that belongs to this file that I'm using here, which is kind of not great because basically Jose Luis right now contains nothing. All right. So let's see on the next video, how can we add properties, how can we add variables to these objects, to this class, like for example, name, age, etc., etc. Let's take a look at how that works. Alrighty. Woohoo! Okay, I need to take a small break. I want to go to the restroom and drink some water. Okay, are you going to stay around? How is this going so far? All right, you liking it? All right, I'll be right back. Give me 1 minute. Thank you. All right, am I back? Yes. Okay. Okay. So. Oh no. Ah, the light. Let me recharge the light. Oh my God, this light is so dumb. Why do I always buy battery-powered things? It's not sustainable. Oh. Okay. All right. Wait. Turn it off. There you go. Okay, so we're going to stay. The light levels are going to be a little different. Maybe here. Yeah, this looks fine. So, can you? This thing is complaining again about the the audio levels. You hear me well, right? All right, template. That will define the properties and functionality of person objects. All right, good. Okay, so let's talk about fields. All right. All right. So in this video, I'm going to talk about adding fields to the person class. All right. Okay, let's do it. Mm-hmm. All right, so as we've seen before, our class person contains absolutely nothing right now. So let's add some variables to what person objects can be. So for example, we're going to add things such as the name, the age, the weight, and whether if the person is alive or is not. Okay, so the way, first of all, remember that we discussed the idea that objects can have variables inside of them representing data, right? And this is very convenient with this idea of encapsulation. I have this object called Jose Luis, which internally is going to contain name, age, etc., etc. All right. So this idea of variables inside of other variables, inside of other objects, is literally what properties and what fields are when it comes to classes. All right. So the way to define variables that live inside of objects is by creating this thing called fields. Fields is just a way of, it's just another word for saying variables that live inside of objects, right? And then literally what we do is that inside of the class person, we're going to define which variables this each person object is going to contain. So for example, we can say, we want to make it so that every person has a name. So what we do is inside of person, we define that each person has to have a field that is called name, which is going to be of the type string. Any person that we define should have a property called age. And that is probably going to be an integer because we typically don't say I'm like 25.7 years old, right? Each person that we define is probably going to have a double value that is going to be the height, maybe, okay? And then we may have a Boolean property that is called whether if this person is alive or if it's not, okay? So by defining variables that live inside of the class, we're creating these things called fields, and fields is just, again, it's just saying variables that live inside of a class. And by doing this, what we're basically saying is that any person object that we can think of or that we can create using this class is going to have these 4 variables inside of it. And which values is it going to have? It will depend on the particular object that we create, okay? So for example, what's interesting now is that I'm going to rename this to JL because Jose Luis is very long as a name. So what's interesting now is that when I go here and I type JL dot, you can see that I'm not really getting anything. I cannot see this name, age, height properties. This is because when it comes to object-oriented programming in C#, this is a very C# specific thing. There's the concept of accessibility that we need to address. And the idea is that by default, if I create fields or methods or anything, and I don't give it an accessibility level, then they will not be accessible to code that lives outside of that class. So I'm not going to get into the details of how that works. That is good when you're writing very complex programs and you only want to give certain people or certain code permission to change things. But for our time being, since we don't really care about that too much, what I'm going to invite you to do is to just write the word public in front of any property of any of these fields that you may want to change. All right. By doing so, look at what's going to happen here. I go back to my main code and I say, all right, in my main code, I'm going to type JL dot, and you can see that now I get a field called age, which is of the type integer. I can also have the height of this person. I also have whether if it's alive and the name. So what I can do now is I can say, well, JL should have a name of Jose Luis. JL should have an age of 100 years old because, you know, it's Jose Luis. He's going to have a height of roughly 178. I'm going to do it in inches so that it's a double. So 5'9". And then JL is going to, is he alive? All right, fine, he is alive, right? So what I'm doing here is that I'm to each one of the variables that live inside of the Jose Luis object, I'm going to give them particular values. All right. So, and now what I can say is, well, if I now console write line jl.name, you can see that this thing pops up here and that I can print my name on the console, right? And I can say, well, let me copy, sorry, what have I done? Let me copy and paste this a bunch of times. And now let's do the age, let's do the height, and you see how it auto-completes very nicely, and whether if I am alive or not. Okay, and then we're going to run this, and then you can see Jose Luis, blah, blah, blah. You can see each one of these properties here. All right, so you can see how now we have created this structure that is of the type people, and that I can use to create a particular object, and I could create another one. So I could create, for example, Jane, and this is going to be a new person, and then Jane is going to have a different name that's going to be called Jane, etc. Right? She's going to have an age, which is going to be 25, etc., etc. Right? And I can now have these two variables, Jane and JL, which each one of them, they both follow the same pattern, but each one of them has different values for different properties. Okay. So this is the core of creating fields, creating variables that live inside of classes. And this is the difference between creating here in the class, creating the general template. So here we're defining that everything, every person has to have these 4 properties, and particular objects that we create with this new keyword thing, we can assign to each one of them different values for each one of those properties. All right. So this is the basics of creating objects and creating properties that live inside of those objects. Let's move on to the next video, where I'm going to explain a better way of giving them these values that is a bit less tedious and less type intensive. Okay, let's take a look at constructors. Alrighty, constructors. Was this clear? How's that going? Jane 25. Jane height is going to be 5.8, and Jane is alive is also going to be true. Okay. Opa. Ooh, I don't want that. All right, and I'm going to print this, and I'm going to print the same for Jane. All right. How are we holding on? I need for this example, I need to system C#. And for this, I'm going to be playing around with dates and years of birth and stuff. Date, time, now. Can I get the returns date, time, now? And then from that, can I get the year? So can I get the year? Date, time, equals date, time, now, and then year. Exactly. What's going on with this? Now whose values can everything convert to from? Okay, yes. All right, so that's going to work. All right, so let's talk about the constructor then. All right, in the previous video, we have seen how we can create new objects of the type person. We have created a custom class called pPerson with 4 properties, name, age, height, etc. And we can see how we can create new objects. And for each one of those properties, we can assign values so that we can start manipulating these objects around, right? And then we've seen how we can print each one of those values, Jose Luis and Jane and all their properties, right? However, this code is a little tedious because I have to actually manually, for each one of the properties, assign initial values, which is kind of tedious. And maybe for 4 properties, it's okay. But if the object was more complex, then it's probably way too much. So there's got to be a way to perhaps make this process of giving objects initial values a bit more streamlined, a bit faster, right? And there is such a process, and the way we're going to do that is by using the constructor function. All right. What does that mean? Well, remember that we said that whenever we want to create a new instance of a person object, for example, JL or Jane, we use this keyword called new. But what this is doing internally under the hood is that it's calling a special function similar to the ones we've seen before, but with a few nuances. It's calling a special function that creates that new object and returns a copy of that object, right? Well, it turns out that we haven't explicitly declared that in our class yet, but we can actually declare how that constructor function works. And let me go here. What I'm going to do here is I'm going to declare the constructor, and the constructor is going to be a special function that we use to create new objects. The way these constructors are declared is that you just use the exact same, this is a C# specific thing, you use the exact same word that you use for the class. So the name of the constructor function has to be exactly the same as the name of the class, all right? And inside of this constructor, I can write any code that I want to run anytime a new person object is going to be created. What does that mean? Well, because this is a function, the functions actually can accept input data. So what I can say is, instead of calling the function empty, so instead of calling the car factory and saying, hey, you want to send me a car? And then they send you whatever, right? Or they let you then, once you send you the car, they let you choose the color and the cylinders like on the spot, like we're doing here. Instead of that, what you can do is you can say, well, maybe when I create the object, I want to give it some initial values through the constructor function. Or with the car metaphor, if I call the factory, I want to tell them like, hey, can you send me a car? And can the car be red? And can I have like 8 cylinders and 4 wheels? And then they send you a car that has all those properties. Well, similarly here, in the constructor function, I can add arguments to give people the possibility of sending initial data for this constructor. So for example, I can say the first argument that it might take is going to be the name. The second argument that it might take is going to be the age. And the third argument that it might take is going to be the height, which is going to be a double. All right. And let's take a live let's treat that a little different, okay? So what we can do now is, because the constructor has been given data, what we can say is, whatever data is coming in from the constructor, I want to store it inside of the value of name, inside of the value of age, and inside of the value of height. So what I can do is I can say name equals name. What? This is very confusing. This is very confusing because I have chosen to call the argument name with the exact name of the variable name. That was really, really confusing. Let me actually rename this for the sake. Let me do N, let me do A, and let me do H. This is really, really bad practice to do single letters here. But what I can say is, so that it's a bit clearer, I can say H equals A and height. Oh, sorry. Yeah, my keyboard is not being working great lately. And height equals H. What I'm doing here is I'm saying anything that you give me when you're calling the constructor, I want to take that name string and I want to store it inside of my internal variable called name. I want to take the A value, and I want to store it inside of the H property inside of my object. And I want to take the H value and store it inside of the height variable inside of my object. So basically, whatever you give me, I'm going to take it right away and I'm going to store it in my internal variables. How does this change what we had before? Well, for example, now the trick is I can say, well, I want to create a new person, but and also we have to remember that this has to be public so that it can be accessible by code that lives outside of the class. All right. So let me say I'm going to create a new person, right? And I'm going to open close parentheses, and you can see how I'm already given these suggestions N, A, and H. All right. So what I can say is this new person is going to be called Jose. All right. His age is going to be 150 years old, and his height is going to be 5.9. All right. And then I'm going to remove all this stuff here. And I'm going to also comment this out for the time being. All right. And I'm going to run this code. You can see how now I have now in my console is printing the name, the age, the height, and is alive, which for some reason initializes by default to false. I'm going to talk about that in a second. But I want to make sure that we understand what is happening here. When this line of code executes, we are passing to the constructor function 3 data points: a string, an integer, and a double. When the computer reaches here, this N has the value of Jose, this A has the value of 75, and this H has the value of whatever, 5 point something. And then that string, Jose, gets stored inside of this variable. This thing, 75, gets stored inside of this variable, and this one gets stored inside of height. So we're basically, again, the metaphor is I'm calling the car factory, hey, red color, 4 cylinders, 4 wheels. And then the guy who picks up the phone takes those data and then just like throws them into the car, and that's what they give you. All right. And then that saves us from the hassle of having to manually change those properties ourselves. So for example, now for Jane, I can say Jane I'm going to create a new person with a name Jane, with an age of 25 and with a height of 5.8. And then as I print this, I don't need this anymore. You can see that now Jane has all these values by default. Not by default, but because I have used them, I have used these values to initialize the person object. All right. So what do I want to talk about now? What do I want to talk about now? I want to change the names of the constructor because I don't like them, and as blah, blah, blah. And I also want to talk about how the constructor can perform operations. on its own, which is a very important topic. Okay, so let's talk about that. Okay, let's talk about a couple of things that I did not like with during my implementation. And as I said before, I really don't like that. It's not good practice that you use very cryptic names for arguments in constructors or in any function in general. So because like when I say here, I'm going to create a new person, blah, 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 you see that the autocomplete gives me NaH. What does that mean? I don't even, it's very difficult to understand, right? So we have to be good designers and design things that are easy and intuitive to understand without needing explanations, right? So I like the idea that this is going to be called name. I like this to be called age, and I like this to be called height, all right? But then we have a very confusing situation where age is equal to age and height is equal to height and blah, blah, blah. And this is very confusing. What is what, you know? And actually the compiler is saying like, oh, you're assigning the same thing to the same thing, you know? So actually you will see in C# that very often code that is written inside of classes, whenever they want to refer to make a difference between what is coming in as an argument from the function and what is actually a variable that belongs to this particular class that we're living, this object, then very typically you will see the word this, the keyword this to refer to, hey, name is what's coming from the argument, but this one name is the one that belongs to this object that we're living in, the one that we are currently inside of. All right. So this is optional. So if this had been before, when these were called N, A, and H, you saw how I didn't have to write this dot name because the compiler assumed that name, the only thing that it found that was name, was the variable that lived inside. So that's why you didn't need the this dot. But when then there is a confusion with names and it could be names are similar, then it's easier to use this to differentiate. Also, it's kind of good practice because it makes code easier to read when you use the this dot notation. All right. And in some other languages, like for example, JavaScript, this dot is actually mandatory when you're referring to variables that live inside of the class. All right. So you will see this very often. And I personally like using the this dot notation to refer to. It makes code easier to write and easy to understand, I think. Okay. Another thing that we haven't seen is what is happening with is alive. So when I create this object, I haven't really explicitly said that whether if this user is alive or not, right? But I already get a value for is alive. So I get here false and false, all right? What happens is that when I create variables that are inside of a class and I don't give them values, they default to whatever default value those types usually take. So for strings, it's an empty string. For integers and doubles, it's the value of 0. And for booleans, it's the value of false. Okay? So we could have said, and so that's why right now, without me working with the giving it any value or whatever, that's why it defaults to false. We might feel inclined to say, well, then maybe what you need to do is add here another argument to explicitly say if this is alive or not. However, I would argue that if we have to specify all the parameters of everything, it's a little tedious. So what happens is that actually inside of the constructor, we can initialize variables. We can initialize values of our internal values, not just from data that is coming outside from the constructor, but through calculations that we can perform internally inside of the constructor. Remember, the constructor is a function, and just here we're making assignments, but we could have like a very elaborate algorithm running in here that performs like very complicated operations and then returns some values that we use to initialize the object. Okay, so for example, a very simple rule here could be if age is less than 0, or if age is if age is greater than some value, so for example 150, whatever, then this is alive is going to be equal to false. All right. Otherwise, we could argue that if that's not the true, then this user should be alive. Okay. For example, right? And then in that case, if I run my code now, then you can see that both Jose and Jane both are true, both are alive. But if I decide to say that Jose has an age of -10, you will see how Jose is the date, so he's not alive anymore, basically. Okay. um, Hey, Parastorm, how you doing, sir? And now let me change the age to year of birth. And we're going to talk about that example. Let me show another example of this idea of using the constructor to perform calculations to smartly initialize the properties of an object. So, for example, here we're working directly with the age of an object, right? For example, for representing persons. But it turns out that when, for example, I would argue that by design, if we're going to be representing people, the age of a person will probably change over time, right? So if I write this program now, but then I run it in 3 years, then the age would have changed. And then, but the age would have changed in the real world, but not in my program. So I would argue that by design, perhaps to representing people by their year of birth instead of their age might be a better design choice. Okay. So for example, what I can do is I can say, well, let me redesign people objects. And I'm going to say that instead of age, I'm going to have now this thing called year of birth. Okay. And I'm going to store this here. Year of birth, sorry, uppercase, year of birth is going to be equal to whatever I get out of the constructor. Okay. And I'm going to cancel this code out right now. And then Jose was born in 1950. All right. And Jane is a millennial. So she was born in the year 2000. Okay. And this is going to be year of birth and year of birth. So if I run this code now, you can see that now instead of age, we're working with years of birth. All right. I can now modify this and say, well, then the factor of whether if someone is alive or not is not so much anymore about an age range, but it's more about comparing the year that they were born to the year that we are currently right now. So something that I can do is in C# you can get which year we are living in by saying I'm going to define a variable called current year here in the constructor, and that's going to be equal to the date time objects. This is like the console class or the math class. There's a date time class that has a lot of functionality for working with dates. We can access what's called the now property. So this basically gives me a datetime object that represents right now. Okay. And from this object, I can also get the property year. So you can see how interesting this is. Datetime has a lot of properties, one of them being now. And that property also has like nested properties, being the year, the second, the hour, the day, etc. So if I get here the year, you can see that it gives me an integer value representing where we are right now, this year. Okay. And then what I can do is I can say if this year of birth is less than current year, all right, then this is alive equals false. Otherwise, this is alive equals true. All right. Simple. So let's see if this works. I'm going to run this code. Jose was born here, then he's not alive, and Jane is also not alive. So maybe year of birth has to be greater than, yes, so sorry, I missed that one. So if Jose, if year of birth is, yes, so Jose is alive, Jane is alive, but if Jose was born in 2025, I'm recording this in 2020 if you're seeing this from the future, all right? So you can see that Jose is not born yet, but Jane is alive, okay? So I just wanted to do this as a way of showcasing that the constructor can actually have some calculations to make sure that given the initial data that you give it, you have something to work with, and that you can perform smart choices to give these values initial property values. To give these properties initial values. Okay. All right, let's move on now. Okay, oh, sorry, I forgot. And constructors, just like any other function, they also accept overloads. So you can create different ways of creating objects. So for example, I'm going to say, this is very nice. It accepts persons that have a name, a year of birth. But what if I just wanted to create like really quick people? All right. So what I can do is I can say, well, I'm going to create another overload, which is going to be, let me create persons, but only with their names. All right. So I don't want to give them any other information. So what I'm going to do is I can say, whenever I'm only given a name, so I can say this name is going to be equal to whatever I am given as data. This year of birth is going to be right now. So whatever, because you're not giving me any information, I'm going to assume that this person was born right now, this year, right? I'm going to assume that the height of this person is going to be, because it's a baby, I'm going to assume that, I don't know, it's like, how big are babies? 2 feet? I don't know, 2 feet. I don't know if that's a big or a small baby. And I'm going to say that this is alive because it was just born right now, is going to be true, okay? What this means is that I can create now, for example, I can create a new object called baby that I'm going to call cutie. This is a terrible example, all right? But if I copy paste this and I say, can you give me all the properties, the name, the year of birth, the height, and blah, blah, blah of cutie, then you can see that my third object, cutie, was born this year, 2020. It's 2 feet high and it's alive because it was just born like right now. All right. So that was just to say that constructors accept overloads. And if you want to remember what an overload is, you can go back to my previous video on functions and the idea that we can define functions that have different names, the same name, but different signatures, different types of arguments and different amount of them to work with data differently. All right. Okay, so let's move on now to these people have properties, but what can they do? What is their functionality? All right, let's learn how to give objects functionality in the form of methods and internal functions. All right. Was that confusing? 22 inches? That's about 2 feet, right? So I was not that far off. Good thing. I'm having problems with the sound. It's clipping. All right. Okay. So was this clear? Let me fields constructor overloads. Constructor just with the name. Constructor with properties. With all right. Okay, so where are we now? We're going to say, we're going to, what are we going to do? We're going to discuss methods, all right? What am I going to do for this one? Maybe I want to start a new file. Let me start a new project. It's going to be 52 person class. Yes. And this one is going to be the same thing, but I'm going to keep only JL here. I'm going to add a method override. Okay, yes. Is today general coding, or would you be coding classes for Rhino? Oh, Spunky, today is just general coding. I'm not going to be doing Rhino today. I want to finish the playlist that we're working in, learning C# for computational designers. We will get back to Rhino at some point in the future. Saeed, if we set a person just with name and age, what will happen if we call that person? It gets it just with the name and the age. So, well, height and so any other properties that we don't initialize will have their initial values. So sorry, their default values. So for strings, it will be empty strings. For integers, it will be a 0. For doubles, it will be a 0. And for booleans, it will be false. They will just initialize. They just initialize to default values. To default values. All right. My keyboard is just not great. It's having object, create a new person object, print its fields to the console. All right. Let's continue working on our person class. And in the previous videos, you have seen how we have been able to create a class representing what properties a person has, name, year of birth, height, etc. We have been able to define different ways of creating objects with different constructors. So creating a person object only from the name, or being more explicit about other data that belongs to that person, right? And we have seen how variables inside of objects represent these properties, all right? Another thing that we may want to add to objects is functionality, right? So people can have names, year of birth, etc., but they can also do things. They can say hi, they can die, they can grow up, they can do many different things. All right. So just like in order to represent properties of an object, we used variables that live inside of those objects. Then to create functionality for those objects, we're going to be creating functions that live inside of that class. All right. So it's the same principle. So I'm going to scroll all the way down here, and I'm going to say, I'm going to create here a set of methods. Methods is typically the name that is given to functions that live inside of a class, all right, or inside of an object. And methods are basically going to be functions that can be called for this particular object. So for example, if this is people, something that I may want to do is I may want to create a function that is called say hi, all right? And then I'm going to open and close parentheses, open and close curly brackets, and this function is going to return nothing. So it's going to be a void function, because the only thing that it's going to do is going to print to the console a message that is saying hi. All right. If you don't remember how to create functions, you can check my previous video. But what I've done here is basically create a function that lives inside of this object. And remember that if I want external code to be able to use this function, I need to add the public accessor. This is a very C# specific thing. All right. So great. So now, because I have created a function inside of my person class, that means that any object that I create from my person class, for example, Jose Luis, will have a new thing that it can do. So for example, JL dot, and you can see that now we have this new thing here in the autocomplete list, which is whether if the person can say hi or not. So I'm going to double click here, I'm going to open and close parentheses, and if I run this code, let's see if I get anything on the console. You can see that I do get this string message here called, hey, hi, how are you doing, right? All right, what was I going to say? Yeah. So this is great. And so now person objects can say hi, right? And this function is interesting because it's just a simple function that returns nothing and it calls this other method from the console write line, okay? Now, we're going back. I don't like that. So this is great, and now all person objects have the capacity to, if I call the say hi function on them, the say hi method, then I will print a message to the console saying hi, all right? However, by design, maybe this is not so great because like all objects saying hi without, I mean, they're all different. Maybe they should say hi in different ways, and maybe like they can introduce themselves, right? When they say hi, like, hey, hi, I'm Jose, right? So it would be interesting to maybe create a method of making the object saying hi in a way that they use some of their own personal information when they spit out that message, right? So what I'm going to do here is I'm going to create another method that is going to be a public void. I'm going to call this one greet, all right? And then what I'm going to be doing is I'm going to say hi, and I'm going to modify this to say I. All right, I'm starting over again. Starting over. Okay, so this is great, but I think the fact that it only says hi, it's a little dull, it's a little empty, and because if all the objects just say hi, then why are we bothering giving them personal, in particular information and different properties, right? So maybe we could improve this method by adding some information so that when the object says hi, it also says like, hey, hi, I'm Jose, or I'm Jane, or I'm whatever, and therefore using some of their own internal information to customize that message, all right? So something that I can do is I can say, well, I'm going to modify this method. I'm going to say, instead of just saying hi, I'm going to say, hi, I And then I'm going to stick to this message. I'm going to stick the particular name that this object has. So I can do this dot name to refer to the name value that is stored in this particular object that we're running the code from, or you could also save yourself this and then just write name plainly. Okay. I like that this dot just because this is an educational video. All right. So let me run this code now. So if I run this code, you can see that it says, "Hi, I am Jose," right? And if I were to run this code from a different object, I actually, where is Jane? I got rid of Jane. Oh, sorry, Jane. So let me create another Jane object. So person Jane equals a new person, and that's going to be Jane. She was born in 2000 and she's 5.8. All right. And then so JLL says hi, and Jen can also say hi. And if I run this code, you can see, hi, I'm Jose. Hi, I'm Jane. And let's give it a bit more expressivity here. I'm just going to write here. There you go. All right. So that's great. So you can see how the say hi method is now using information that lives inside of the class, which is really nice because now the behavior of each one of the objects depends on their data, depends on of like internal information that they contain, and that's actually the power of why object-oriented programming is so interesting and so cool, right? So for example, let's say that this is going to be a little grim, okay? But we know that when we create objects, we can say that whether if they're alive or dead, right? So something that we can do is when we create methods, we can not only use those methods to read information that belongs to the object, but also we can use those methods to change information from that object. Okay, so for example, if I were to create a public void function called die, and this is a little sad, right? But whatever. What I can use this method for is I could say this dot is alive is not whatever it was before is going to be false now. Okay, so what I can use that for is, let's say I'm going to kill. Let me kill Jose Luis. So Jose Luis, let's print first of all. Let's print. Console.writeLine JL.is alive, right? And then I'm going to kill him, boom, and then I'm going to print the same thing over again. All right, so I'm going to say yes. Where is my window? Okay, so I'm going to say, yeah, Jose Luis, when it was created, Jose Luis was alive, but then Jose Luis was killed, and then afterwards, the value of whether if he is alive or not is not true anymore. All right, does that make sense? So methods can be used to read information from the object, but it can also be used to change information from the object. They can also be used to calculate information from the object. So remember in the video when I said before, we're going to change from defining people by their age, we're going to change to defining them by their year of birth, all right? Because this is more interesting. If we were to store these things in a database, we want year of birth because then we can calculate their age on any year after we run this program, right? So, but right now, there's no way for us to get the age, right? So we can actually calculate the age, for example, by saying, I'm going to create a public function that is going to return an integer, that age, and I'm going to call it, for example, get age. All right, and I'm going to do that by saying, well, how do I calculate the age? Well, the age has to be whatever year we are on right now minus the year of birth. So what I can say is I'm going to return the year that we are right now, so date time dot now dot year minus this year of birth, the year of birth for this particular object. Okay, so Jose Luis say hi. So we're going to print here console write line. So for example, JLH. That's going to be equal to JL.get the age of this object, and let's print that to the console. JLH. And it turns out that Jose Luis is 70 years old right now, okay, because he was born in 1950, okay. So methods are also very common to perform calculations that relate to the particular object. In this case, I'm using the information that lives here to perform some calculations. And this code, I like it a little better now when it comes to representing people, because by storing the year of birth, that's going to be immutable. That's never going to change. But the age may change depending on when we are running this program, right? So I think the person class is a bit better now. I like it better conceptually by design, right? The lesson that I want to talk about is I want to make the greeting part even a little better, because I want to show you the fact that we can actually, the methods that we have created so far were simple functions that didn't take any information and they return nothing, or they return a number, right? But I want to show you how methods can also take information. They can take arguments just like any other function, and we can use that to work and make them smarter. So for example, the say hi function was a little dry because like this person was saying, hi, I am Jose, but it wasn't really greeting anyone. So I'm going to actually change this to the word greet, okay? And I'm going to create some overloads where I'm actually going to implement a version of the greet method that actually says hi to someone. All right. So for example, I'm going to say public void greet, and then I'm going to create an overload because it's going to have the same name, but it's going to have a different types and different amounts of inputs. So I'm going to say, well, this function, this method is going to accept the name of another person. And then what I'm going to do is I'm going to print, hi, other person, other name, right? And I'm going to close the curlies, and then I'm going to say I am my name. So the message here is going to be, hi, whoever, I am my own name. All right. So now, for example, here I'm going to delete. I'm going to delete this stuff here. Now I don't have say hi anymore. I have greet. So remember, if I call greet just on its own, what I'm going to get is why am I not sorry. What? Yes. So what I'm going to say is like I only get hey, I am Jose. But if I call this method by saying greet, I want to greet Jane here, right? So I'm going to pass in the name Jane, and then you can see how now the other overload is called, and this thing has hi Jane, I am Jose. All right. So that's great. Okay. But wait. So I want to greet Jane, and but it turns out that Jane is already something that is living here in my code, right? So maybe what I can do is I can say, well, maybe instead of passing the string Jane, because what if I change the name here and Jane is now Janine or Jennifer or whatever, right? So I would have to manually change this here. So I can make this a bit more programmatic by saying, I always want to greet whoever is Jane, whatever her name is at any given point, so that if this name ever changes for whatever reason, my code still greets the same person. Okay, so I can say I want to greet Jane.name, because since this method takes a string, the name property is a string. inside of Jane. So you can see like, hi Jane, I am Jose. Okay? But wait for it. Wait for it, because if I'm always going to be greeting a person, and I know that person objects always have names, because that's what I have defined as part of how the person class works, all right? Then maybe having to explicitly say that I need to greet the name Jane as opposed to the person Jane is it's a little redundant. So maybe I want to be able to write cleaner code that says I want to be able to greet without any name. I want to be able to greet Jane as a name, as a string, but I may also want to be able to greet Jane as an object directly. So given a Jane object, I may want to be able to greet her directly without having to read the name property of her. So how does that work? How can I do that? Well, it turns out that because I have now created a person class that has all these properties and all this functionality. And we discussed before how when I do that, then person as a thing also becomes a new type of variable that I can use for JL, for Jane, etc. But it basically becomes a new type. Then I can use that type as data types that I can use in other methods, in other functionalities, in other algorithms, etc. So for example, in my overloads, I can say I may want to have a function that greets whoever without a name. I may want to have a function that greets a particular string name that I have been given. But I may want to have a function that says I want to be able to greet some person object that you're giving me. You know? And if the input of this function is of the type person, then I know that what I can do is, because I know that person objects always have a name property, I can say, I'm going to greet from the other person, I'm going to greet that person using their name property. Oh, what? And if I do this, you can see how, hi Jane, I am Jose. This is the third one. All right, let me clear this up so that it's not so confusing. All right, and you can see how now I'm greeting Jane, and I know that person objects always have a name property. So that's why this function can now work by taking person objects and then from their person objects reading their name property. All right. What? All right. So the fact that I'm using a person class here is independent from the fact that I am inside of the person class. All right. The idea is that now person as a data type can be used anywhere in my program, anywhere that there is access to the person class. All right. So how was that? This is the beauty of object-oriented programming. Now that we have person classes, or that you have any custom class, you can use that as data type and exchange that data type with other methods, other algorithms, and work more smartly with your data. All right. Let's move on to the next video where I'm going to explain one very important and particular method that all objects have and that is very convenient for us to work with. Ooh, Arasto, yes, overloads can return different types. And so an overload can be, this overload may return nothing, but this overload may return a string. And then you here, the only thing you have to do is like, you have to return something here. Return something, you know? But yes, different overloads can take different inputs, but can also have different signatures for the return types. All right, so I want to talk about the toString method override. What does that mean? Um, how am I going to do that? Okay, I'm going to create a class. I'm going to create a new project. Yes. How are we holding on? I think I'm going to do one more video right now. It's going to be very short, and then I'm going to take a break for lunch, and maybe we can do like a little bit of Q&A and social before we break for lunch. Okay. I'm going to create a new one. It's going to be a person class. And then I'm going to say, oh my God, jl.name, year of birth, get age, height, and whether it's alive or not. All right. And then I'm going to have the public override to string. All right. Okay, I think this is where I want to start. Yeah. All right. All right. Let's do this. So we're going to write the toString method. All right, let's do this. Continuing with the topic of methods that belong to classes, I want to discuss like one very useful technique that I use all the time and that I really encourage you to take a look at. And it is the fact that very often, for example, when we create objects, right? Objects have a lot of properties inside of them, name, year, blah, 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 whatever. So, and I can create them with a constructor in a very lean, fast way. Okay. And it turns out that if I had a very complicated program, right, that I created an object, and then at some point I wanted to just check visually in the console all the properties of that object, then it would be a little tedious because right now, remember, I would have to write something like this, where I would have to write for each one of the properties, I would have to write a console write line situation and print the name, the age, the height, whether if the person is alive or not, etc. But this is a little cumbersome because for 4 properties, maybe it's fine, but if I had like 17 of them, maybe it's a little too much. I may want to do something where I just want to print the object itself, the whole thing. I just want to throw it into the console and get a printout. But with the default techniques, it turns out that, what is going on here? Wow, yeah, my keyboard is kind of crazy today. It turns out that if I just throw the object into the console without without any other thing, what I get is this default string representation of the object, which is the name of the class and the namespace that it belongs to. All right, but it doesn't really print the information. Why doesn't it print the information? Well, the computer assumes that these objects can be of any shape with any kind of properties, whatever, and it doesn't know really what you may want to print. So it defaults to this string representation that is honestly not very useful. So what we may want to do is we may want to customize how by default objects get stringified, how objects become string representations of themselves. And the idea to do that is that we can go to our class and then we can use a special method that all objects in C# have. I'm not going to get into the details of this, but when you create an object, when you create a class, all classes inherit some really basic functionality from the ideal class, which is the class object. This is I'm not going to get into what this means, but what it means is that by default, without you even saying it explicitly, every class that you create has a method called toString. And that is a method that is called whenever an object needs to be turned into a string so that it can perform some function, like for example showing up on the console. So even though we haven't talked about this yet, but this here is printing because secretly the compiler is calling the toString method of this object, and this is what that method returns. We don't have control over that because that is something that is being given to us out of the box, almost secretly from the C# environment. But it turns out that we can actually customize that behavior. So what I can do here is I can go and say, I could write a function here that returns a string, and I'm going to call it toString. All right, and this has to have this one particular name. All right. This is the name of the function that is a standard default method in C# environment. All right. And what I can do here is I can create a string representation. I can customize how this string is going to look like for me. So for example, a way to do that is it's going to be string obj. This is going to be, for example, I don't know, how do I want to represent people? I may want to open, I may want to use, for example, I forgot how to do string interpolation. I always, because I've been writing a lot of JavaScript lately, string literals in C#, string interpolation. Yes, all right, yeah, okay. And I may just want to represent this object like this. So for example, the object is going to be represented with like square brackets, and then here I'm going to write this dot name, all right? And then the second one is going to be the age. So instead of using the year of birth, I may want to represent the age. So I can call the getAge method and print the return of that method. Here I may want to print the height, all right? And here I may want to print whether if this person is alive or not. And then I may want to close the square brackets and or without the square brackets, because I don't want to indicate that this is an array. It's not really an array. And then I can return this object. All right. Remember that here I'm using string literals. I made a video on string literals at some point. It was somewhere in the playlist. Okay. And the only thing that I need to remember is that toString as a method already exists in objects in C#. So I need to add a particular clause here that is called override to say, I don't want you to use the default implementation, the one that gave me the namespace and the name of the class. I want you to use this one that I just wrote here. So that's why I want to override the default behavior that the toString method that comes out of the box uses, and I want you to override it with this particular implementation that I just created. And what's nice about this is that now when I print the object, this object is going to serialize itself into a string that is going to look like the format that I just wrote here. The name, comma, age, comma, height, and whether if it's alive or not. All right. I could fancy this up by writing name, colon, Jose, age, colon, 70, or whatever you want. At the end of the day, this is about how do you want to customize how this object looks like when it becomes a string by default. All right. So when creating classes, it's super useful to customize the string method, the toString method, so that when you are developing and when you're printing to the console, or when things just need to become strings, then they use this method instead of the default implementation. All right. I really encourage you when writing classes to do that for yourself. It's very useful, and it's very you will be very happy with yourself. Okay. All right, let's move on. Alrighty, and I think with this, I think I'm done for the morning. I want to take a break and have some lunch. Do you have any questions, things you want to ask, topics you want me to cover? I have a few minutes to do some Q&A, some social. Otherwise, I'll see you back at 2 p.m. my time, so in about 2 hours from now, a little less than 2 hours from now. I'm going to give you a minute to post anything on the chat if you want to ask something. I think I'm okay, happy with this video so far. Any questions? The last one was crazy. The toString method, what was so crazy about it, Said? I actually think this one was a bit more crazy when we talk about function overloads, method overloads. This one is pretty, I think what you find crazy is this string literal, which is a little hard to read, right? All right. Oh, Archicoder, you're not Spanish? Oh, I thought you were Spanish. I'm sorry. Don't worry. No worries. Where are you from then? Hmm? Alrighty. So, oh yeah, when I was showing this, you were not seeing. So I was saying that I think for me, this is conceptually it's a bit more complicated to understand, I think. Yeah, Arasto, the Jane thing was crazy when you were passing Jane to Jose, right? um, but um, but yeah, so yeah, but I think the confusion was that the string literal is a little difficult to read. Huh. Yeah. Oh, from Poland, kurwa, kurwa much. Oops, sorry, I shouldn't have said that. That's how far my Polish goes. No, I also, what do I know how to say? Just mi zimno, bo kalorii fernie jabła. Yeah, I've I had a tough, I had a rough moment in Poland. Oops, sorry. Oh yeah, Monique, you're also Polish. I forgot. I'm sorry. Okay. All right. So I think with that, with my Polish skills, I'm going to leave it today. Thanks everyone for sticking around. And I will be online again in 1 hour and 45 minutes at 2 p.m. my time. And now we're going to wrap up classes. I want to cover properties. I want to cover with getters and setters. I want to cover static methods and static properties. And I want to cover structs. I want to cover Oh, references and values, and then I want to make the vector class. Oh, it's gonna be tight, huh? All right. Okay. Okay. Thanks a lot, and see you later. Bye.